question is the constant pressure heat capacity of a sample of a perfect gas was found to vary with temperature according to the expression. So we have this expression, that is Cp, that is heat capacity at constant pressure in joule per Kelvin, and it is 20.17 plus 0.4001 into T in Kelvin. It is given to us Cp. Now we have to calculate, and it is a perfect gas, means it is an ideal gas, right? So we have to calculate Q, W, delta U and delta H when the temperature is raised from 0 degree Celsius to 100 degree Celsius. Means temperature T1, it is 273 Kelvin, and temperature T2, it is 373 Kelvin. So these are the two temperatures. Now we have to calculate these values Q, W, delta U, delta H, first at constant pressure and second at constant volume. First at constant pressure. So at constant pressure, you know, this W is equal to minus P delta V.
Yes.
And at the same time, it can be written as, if you know temperature varies, so it can be written as minus NR delta T.
Yes.
So constant pressure heat capacity of a sample of perfect gas was found to vary. That means moles are not given.
Yes.
So we take it as 1 mole. That is standard. If number of moles we have to mention and they are not given to us, we have to take it as 1. Okay, so work done is equal to minus 1 into 8.3, or you can write completely 8.314 into 100.
Yes.
Because delta T, that is T2 minus T1, and it is 373 minus 273 means 100 Kelvin. So in this way, work done comes out to be minus
831.4.
yes. So this is the amount of work done at constant pressure.
Yes.
Now second is Q, delta U and delta H. So let us calculate delta H. You know, we have done this part, Cp equal to delta H by delta T, right? And delta H is equal to Cp delta T.
Yes.
But here, you know, there is a variation from 0 to 100 degrees Celsius, and at the same time Cp changes with temperature. Every time when temperature changes, Cp goes on changing. Cp is not constant.
So to be integrate?
Yes, then we have to integrate it. So it is Cp into dt.
So we change delta T to T.
Yes. So what is Cp?
Cp is 20.17 plus
into T into dt, and it varies from 273 to 373, T1 T2, so it is 20.17 into T, 273 to 373 plus 0.4001 multiplied by T square by 2. So 2 take it as outside the bracket, and it is 373 square minus 273 square. So just calculate the value. So how much time they have given for 30 questions?
For 30 questions, it is 2 hours. But not 2 hours, 1.5.
Okay, then it's okay. Otherwise, see, this question is somewhat time taking, right?
It comes out to be 14.9 kilojoules.
40,
14.9
14.9
kilojoules.
kilojoule. So this is the delta H. Now we know that this is now if we talk about delta U, it is again same, but now it is Cv dt.
Alright.
So instead of Cp, now we will write it as Cv. So what is the relation between Cp and Cv? Cp minus Cv equal to R.
Yes.
So Cp is equal to Cp minus R.
Yes.
So Cp is 20.17 plus 0.0, sorry, 0.4001 into T minus R. R is 8.314. So Cv comes out to be, what is Cp? 20, you can take it as 8.31.
Yes,
11.86 minus 0.4001 into T. So now delta U is okay, plus, sorry. So it is integration 11.86 plus 0.4001 into T multiplied by dt. So value comes out to be 11.86. Again, temperature is same, 273 to 373. So 11.6 into T, that is 373 minus 273 plus 0.4001 into T square upon 2. So it is again 373 whole square minus 273 whole square. So now delta U, what is the value?
Yes, sir. It comes out to be 14.1 kilojoules.
14,
14.1 kilojoules.
14 point, 1 kilojoule. So now delta U is 14.1 kilojoule, delta H is 14.9 kilojoule, and W is this one. So from W, okay, so in terms of kilojoule it is 0.8314, so take it as 0.83 kilojoule. So this is the work done. So you know delta U is equal to Q plus W. So Q is equal to delta U minus W, and delta U is 14.1 minus 0.83. So yes, it comes out to be 7 to 13. Is it okay?
This is the value for
Q.
Q is given as 14.1 kilojoule itself.
14.1.
Yes.
14.1 is Q. And what is delta U?
Delta U is delta U is 14.1 and Q is not given.
Actually, delta U is QB, right? And delta H is QP, heat absorbed or evolved at constant pressure.
At constant pressure, Q is equal to delta H, right?
Yes. And at constant volume, it is delta U. And what is W?
W for
At constant pressure.
W for constant pressure. It is minus 831 joules.
Yes. So it's okay, right?
Yes, sir. Yes, sir.
So Q we can calculate because by applying this formula, delta U is Q plus W. Okay.
Yes.
So total heat absorbed or evolved, we can take it as delta U minus W.
Yes.
Okay. Now, second part is at constant volume. So as volume is constant, we know W is straight 0.
Yes.
Okay.
So Q and yeah, so which is why Q is equal to delta U.
Yes. Now Q is equal to delta U. In this case, Q is equal to delta U, and the value is same, I think. It
14.1.
Yes, and delta H is also same.
Yes.
Okay. So just write down with that. It doesn't make any difference. It only changes work done.
Yes.
And at the same time Q, that is equal to delta U, because it is at constant volume.